Hello guys, welcome back to my YouTube channel. I'm Peter Monyaka and we are going to look at CPU scheduling algorithms. This is a processing executing in CPU, and I want us to start with shortest job first. It is also called shortest job next, whereby the shortest job, which it is the one which has the least burst time, will be the one executing first. Now when we find a question like this, we just first draw the Gantt chart. Here is the Gantt chart we have already drawn. You start when time is at 0. We check at the arrival time. When the time is at 0, which process is already in the CPU? Consider it's P4. P4. It has a burst time of 4. Now P4 is already executed. At time 4, you come back to the Gantt chart, you check whether at time 4, which process has already arrived at the CPU. Time 4 we have P5 here. P5, it is allocated with a burst time of 5. Now you add 5 plus 4, you get 9. Now guys, when the time is at 9, it means that they have already arrived to the CPU. Now you consider to the burst time, because you want to look about the shortest job first. The one which has the least burst time, it is the one who is going to execute first. Now let's look. P5, P4 and P5, they are already allocated to the CPU. Now at time 9, they have already arrived to the CPU. Now we consider the burst time. We just add the least burst time is P2. P2, because it has a burst time of 3. 9 plus 3, you get 11. Yes, now we continue. Now P2 has already been allocated. It is already gone. After that, we check which one has also the least one. It is been followed by P1. P1, it has 7. Now 11 plus 7, you get 18. Now P1 has already also been allocated to the CPU. Now our last process to be allocated to the CPU, it is P3. P3 here with a burst time of 9. P3 with a burst time of 9. Now 18 plus 9, you get 27. Now we have already drawn our Gantt chart. Now we want to fill this section of completion time. Completion time is the time which the process have took for it to be executed after being allocated to the CPU. We want to see at P1, which is the the completion time of P1, it is 18 there. P2 is 11. You come and check to the Gantt chart. This is helpful for you to know the completion time. So P2, it has 11 there. We come at P3, which has 27. There we want to look at P4 also. P4 has a completion time of 4. Next, P5 has completion time of 9. Now we are right. Now we want to fill this section of turnaround time. Turnaround time is completion time minus arrival time. It is the all time for the process after when it has been arrived to the CPU until it is being executed. Now turnaround time is equals to completion time minus arrival time. So let's check out this P1. P1, it has a completion time of 18 minus arrival time of 2. Now total turnaround time is equals to 16 there. And also P2, it has completion time is 11 minus 5, the arrival time, you get 6. And then P3, completion time is 27 minus arrival time of 1 is 26. And then we continue. P4 has a completion time of 4 and it has arrival time of 0. So 4 minus 0, 4. And then at P5, last one, it has a completion time of 9 minus arrival time of 4. So we get turnaround time is equals to 5. Now we want to fill this. After calculating the turnaround time, we want to know the waiting time of each process of P1, P2, P3 all the way to P5. And we know that waiting time is equals to turnaround time minus burst time. And now we want to check on P1 here. Turnaround time of P1 is 16. Burst time of P1 is 7. 16 minus 7, you get a 16 minus 7. Now 16 minus 7, you get 9. We have shown that 16 minus 7 is 9. Now at P2, turnaround time minus burst time is equals to 6 minus 3, you get 3. And then at P3, it has a turnaround time of 26 minus 9. 26 minus 9, you get 17. And then P4, turnaround time is equals to 4 minus burst time of 4 is equals to, it has a waiting time of 0. And then P5, it has a turnaround time of 5 minus arrival time of 5, so is equals to 0. Now right there, we have already calculated the turnaround time, completion time, and also the waiting time. We are remaining with the response time. Now the response time, it is being tackled by the time when the process got fast to the CPU minus its arrival time. When the process entered allocated to the CPU minus the arrival time. Now we want to check on P1. P1 arrived to CPU at 11. 11 minus arrival time of 2, you get 9. 9, yeah. Now we want to, that is the response time of P1. Of P2, P2 arrived at the CPU. P2 arrived at CPU at 9. Yeah, at 9 minus arrival time of 5. So response time is 4. And then P3 arrived to the CPU at 18, and I was allocated to the CPU at 18 and arrived at 1 at time 1. So 18 minus 1, you get 17. And then before I was allocated to the CPU at time 0, but also arrived at time 0. So 0 minus 0, obviously is 0 there. And then P5 last one, it was allocated to the CPU at time 4. Time 4 minus 4, you get response time of P5 is 0. Now, after done that, we want to calculate the average waiting time. Average waiting time, average waiting time, average waiting time. You add all the waiting time from process 1 to process 5. That is, the waiting time is here. Get 9 plus 3 plus 17. And then the others are 0. So just leave them. Divide by, how many are they? 1, 2, 3. Divide by 3. Divide by 3 there. 17 plus 3 plus 9. Divide by 3. So we get that waiting time is equals to. Now by calculating the waiting time, you add all the processes in the CPU. You have process 1, process 2, process 3, process 4, and process 5. You add 9 plus 3 plus 17 plus 0 plus 0. You divide by the number of all processes. How many all processes that do we have? 9 plus 3 plus 17. We have 5 processes. 1, 2, 3, 4, 5. 5 processes. Now when you add, you get 29. Divide out of 5. So average waiting time is equals to, average waiting time is equals to 29 divided by 5. That is 29 divided by 5. That is 5.8. 5.8. Now that is the average time, which is the unit is microseconds. The unit of the time for the waiting time is microseconds. Now thank you learners. Thank you guys because you have took your time. Now this is how we deal with shortest job first. We have said that it's also called shortest job next. Now thank you. You can go to the YouTube channel and search Peter Munyaka, and there you like, share, and comment. Yes, let's meet to share the next tutorial, which is the first come first serve, round robin, and all other scheduling of algorithms. Thank you.